You're listening to the Big Blue Marble Podcast with Anwar Knight.
Well, the thing is that we brought this on ourselves. A pandemic like this has been predicted. We've had epidemics galore, and it's because we have disrespected the natural world and the animals who live there.
We brought this on ourselves. Powerful words from Jane Goodall during a recent interview with Christiane Amanpour about the pandemic. You certainly recognize her name. Goodall, renowned for her landmark research on chimpanzees, almost 60 years actually of groundbreaking work, and to this day she continues efforts to promote conservation around the world, and she's 86 years old, so just a remarkable human being. But what does conservation have to do with the global pandemic? Well, how long do you think we could keep going on like this? Come on. At some point, the exploitation of nature was going to catch up to us. We just can't take. You know, a report from the World Wildlife Fund revealed that we've lost 60% of all wildlife in the last 50 years, and at the same time, the number of new infectious diseases has quadrupled in the last 60 years. So there's an undeniable connection between emerging diseases and how they are linked to environmental alterations that are caused by us. Do you remember the Ebola epidemic a few years ago? Killed more than 11,000 people across West Africa, and scientists have now linked the outbreak to rapid deforestation. And one researcher, a professor at Manchester Metropolitan University, says simply, because humans are now in much more contact with animals when you open up a forest. There used to be a buffer, but now in parts of the world, we are putting together people, animals, viruses, and bacteria. It's like one giant petri dish. Let's see what happens. COVID-19 happens. In the 1990s in Peru, malaria cases rose from 600 per year to 120,000 because of a single road that was built into a forest and people began clearing their lands. Researchers determined that the malaria-carrying mosquito species bit 278 times more frequently than the same species in an untouched forest. These are just a few of the early warning signs, but because it happened over there, we didn't tune in. But we are now. The world has forever changed because of this new type of coronavirus that has virtually knotted up humanity. Everything we do is now different. Some are describing this pandemic as nature's backlash. So coming up on today's show, we chat with Miss Felicia Keysing, an ecologist and expert in this field. We'll find out why this pandemic was not a surprise for some, what animal is most likely to spread the next infectious disease, and most importantly, what we, you and I, can do to hopefully prevent it from happening again. Plus, we'll update the Blue Files and find out how COVID-19 could be affecting your local weather forecast. Really quite fascinating. It's all coming up. I'm Anwar Knight, and this is the Big Blue Marble Podcast.
Have a question, comment, or show idea? Let us know at bigbluemarble.earth.
It is a real pleasure to welcome ecologist Felicia Keysing to the Big Blue Marble Podcast. She is a professor and educator at Bard College in Annandale, New York, and has conducted extensive research on the consequences of unbalanced interactions among species and the risks associated with that, particularly as biodiversity declines. Thank you, Ms. Keesing, for your valuable time today.
It's a pleasure to be joining you.
It's great to get your insight and expertise on this pandemic, and we connect at a time when we can at least finally see a small flicker of light at the end of this long, dark tunnel, with some sort of normalcy beginning in various parts of the world, including here in North America. But without question, it still remains, by and large, unpredictable at the moment.
Indeed.
I have to wonder, though, while much of the world was understandably shocked as this started to rapidly unfold, I'm thinking for researchers like yourself, though, the coronavirus was likely not a surprise to you.
That is true, unfortunately. I think in our worst case scenario, we envisioned a viral pandemic that looked something like this. It was a worst case scenario. And a number of people who do what I do have been warning about the possibility of something like this happening for years now.
Isn't that something? So what we are seeing now was and is the feared worst case scenario.
There was a team a couple of years ago that projected pretty much this. They envisioned something that jumped to people, got spread by aerosols, the sort of coughing and sneezing route. And then if it wasn't contained early because of global travel, it would spread and if it could be transmitted before people knew they were sick, which is the case for this virus, it could spread globally. And once it's doing that, that they predicted that it would disrupt the global economy in pretty dramatic fashion. And again, that was the worst case scenario, but we've already seen a number of viruses that have jumped and wreaked much more modest havoc. But we certainly had warnings in SARS and MERS and Ebola that this kind of thing was possible.
Yeah, and I guess in hindsight, at least when it comes to SARS, that pathogen really helped some countries prepare for what we're dealing with now. It's hard to believe it was 17 years ago, and at the time it was very scary, but the numbers... Now, when you compare the two, it's just staggering. SARS had just over 8,000 confirmed cases in 31 countries, compared to over 5 million cases in over 200 countries now with COVID-19. But there is another parallel between the two, and that is the speculation on where it originated. Early evidence suggested it was a wet market in China, and that theory was further advanced by Mr. Peter Ben Mbarak. He's with the World Health Organization, a food and animal disease expert. He noted that he believes a market in Wuhan selling live animals likely played a significant role in the emergence of the coronavirus. So have researchers at this point been able to pinpoint definitively the original source of COVID-19?
Yeah, we don't know what the source was, and we don't know exactly what happened. The best evidence for now is that the jump from an animal to a human occurred in that Wuhan wet market, but we're not absolutely sure. I mean, one of the ways that we would figure this out is that we would find 100% genetic match in a creature other than humans, and that would suggest that creature was the source of the virus to us. So we don't have that creature yet. We don't know what that was. Some people argue pretty strongly that it must have been a bat, and others have said it was likely a pangolin, or maybe there was some mixing between bat and pangolin. But the reason there's that speculation is because we have not found 100% match as a possible source. We found things that are 96% closed or somewhere around there. And at that level, we can say, well, maybe the virus we have has an ancestor in one of those species, but that species was not the actual source to us based on the evidence we have now.
Do you think we'll ever find out?
I think it's possible, but it will take a long time, especially now that we have so many movement restrictions and laboratory restrictions around the world. Because the only animals other than humans that we've seen 100% match in are actually ones that we've given it to. So even if we find 100% match now, we have to be a little careful to distinguish whether it was something we gave it to. We can give it to tigers, to lions, to Syrian hamsters, to llamas. So we're going to have to be a little careful now when we look at 100% matches.
Well, I'm glad you brought that up, actually, because when I saw that report initially, that lions and tigers at a New York zoo had the virus, at first I thought, maybe that's just common among these animals. But in actual fact, they contracted it from the keepers, so humans have passed it on. There's also a mink farm as well in the Netherlands, also infected by the workers there. In theory, then, I was thinking that, this is a cycle that just could keep going then. How could we possibly catch up to this if it is passed back and forth?
Yeah, so if those animals can shed it, that is a possibility. So what that would mean is that where we were very upset that something passed it to us, that we actually have become what we would call the amplifying host that's passing it to other creatures. So look, I would just cut to the chase and say that there is no good path out of this short of a vaccine that I can see from here. So if once we have a vaccine, and fingers crossed that we get one, then it will matter less to us if other animals have it. For our own self-interest, we would then need to worry whether it's having negative effects on those other animals, because it could matter a lot to them.
Yeah, and I think we're so intimately connected with nature, whether we like it or not, or aware of it or not. And as such, there are eventual consequences if we continue to disregard the significant role that nature plays on Earth. I really believe that. So as catastrophic as this has been on the human population, there's also this impending ecological threat. What it could possibly do to already endangered species.
Yeah, I mean, I think that there is concern around the world about ways in which the virus that causes COVID-19 could be transmitted to wildlife, and particularly endangered populations. I think it's quite plausible to imagine that humans could infect gorillas or orangutans, for example, with this virus, and potentially with absolutely devastating consequences. So, this we talk about how we're all in this together, right? When we're talking about battling this virus, but I would expand the orbit, perhaps, of who's all in this together. It's not just humans that are in this together. It's every living thing on this planet is struggling with this, and with the environmental challenges posed by the dominance of humans on the earth.
You are absolutely right. This is an alarm bell for every living thing on the planet. So how does this evolve, though? How does a virus like this begin? Is it just close contact, human and animal? Is it consumption of that animal? Is it fluids that enter through a wound and open skin? Where does this start?
It could be any of those things that you described, but it depends on the virus and a little bit on the animal. So from humans, the virus that causes COVID-19 is spread from a variety of different routes. For example, we know that what we're all thinking about is the way that it's spread as an aerosol, for example, through coughing and sneezing, like other respiratory viruses. But we also have some evidence, and this is maybe a little unsavory, but we have some evidence that the virus can pass through our digestive system and come out in feces. Whether that's then transmissible to others, I think, has not been determined. But we know that there are multiple routes through humans. We could suspect that those same routes are possible for other creatures. But since we don't know that much about the source, we don't know. But again, different viruses are passed in a respiratory way. They can be passed through feces. They can be passed through bodily fluids, particularly blood. So you could get them by being coughed on or breathing in some aerosols, or by coming in contact with bodily fluids, as you say, through a cut. But it would depend on the particular virus, which would be the route. COVID-19 virus, the SARS-CoV-2 virus that we're battling right now, seems to be primarily respiratory, but again, this is all still under very active investigation.
So at this point, even the transmission of the virus, when it first started, is still speculative. We know now human to human, generally through aerosol or coming in contact with bodily fluids, but from the birth of this pandemic, how it actually infected a human being in the first place, we don't know.
No, we don't know 100%, because we don't know exactly where it happened and exactly from what it happened. But we can say that if it happened in the wet market, in fact, wherever it happened, it was exacerbated by really close contact between human and whatever the source animal was. And if the conditions were crowded for either the source animal or the human or both, the transmission would be more likely, in part because an animal under a lot of stress would be likely to shed more virus particles, and humans in very close contact would be more likely to pick it up. So we certainly know the kinds of conditions that make the transmission more likely, but again, we don't know exactly what happened.
Will it mutate once it enters a new living host, such as a human being?
Viruses are constantly evolving. It's one of their sort of superpowers. They are very simple particles that don't have that much genetic material, and they don't have that many structures that make them up. And so they can actually undergo mutation at a fairly high rate without sort of creating devastating problems in how their whole, I keep wanting to say organisms, but they're not really alive, and on how their whole structure functions, because they're so simple. So a little tweak here or there changes the nature of a protein, but doesn't necessarily debilitate the whole particle. And so they actually mutate fairly quickly. So for example, we know that the SARS-CoV-2 virus, the one that causes COVID-19, has already mutated as it travels from human to human, and we can track that by just looking at little changes in the genetic sequence of this virus.
Mm-hmm. Now, as I understand it, a majority of all emerging infectious diseases like COVID-19 are what's called zoonotic, meaning a disease that passes from an animal or insect to human, correct?
Mostly correct. A zoonotic disease is one that passes from a vertebrate animal to a person. So a vertebrate is something like a mammal, a fish, a bird, a reptile, an amphibian. So we would keep insects out of that. Insects and other arthropods are often the vectors. They move the pathogen from one host to another. But most emerging infectious diseases come from vertebrate animals.
But fair to say that zoonotic diseases, in fact, impact the health of millions of people every year around the world, right?
Absolutely. Yes, they do.
Okay, so this is what perplexes me, because a majority of the free world was oblivious to this. That is, until now. So why is this disease so different? What do you think happened here that made the virus so powerful and deadly?
Well, yeah, I've thought a lot about this. What is it about this particular virus? What I would say in simplest form is there's no single feature of this virus epidemiologically that makes it stand out. But what it has is a sort of perfect storm of traits that make it able to do what it's done. You know, its infectiousness, its incubation period, its mortality, its fatality rate. But I would go back to your point about zoonotic diseases, just to make the really important point that when we realize that 3/4 of emerging infectious diseases of humans are zoonotic, meaning 3/4 of them come from vertebrate animals, it would be easy to make the assumption that then wildlife and other kinds of animals are dangerous to us because they're sources of these viruses. But in fact, most animals are not sources of these viruses. The vast majority of viruses, of zoonotic viruses and other pathogens, come to us from just a couple of groups of mammals. Rodents, by far the biggest source, and bats are second by a fair bit. So it's not biodiversity in general we need to be concerned about, it's rodents.
That is really interesting. And yet, to be clear, we don't think rodents played a significant role here with this particular virus.
We don't, but when we look at other zoonotic diseases that have emerged and wreaked havoc in human populations, rodents are often the sources of those, whether that's viruses or bacteria or other things. And so what's interesting is that we can understand partly why rodents are the likely source of zoonotic pathogens, because most mammals actually are rodents. They make up almost half of all mammal species. So they're just the most likely, kind of mammal to run into. But they have a bigger role than that. And that's that they actually thrive when biodiversity is lost. So when we destroy habitats, when we erode biodiversity because of all the things that humans do out to the environment, we're actually creating the conditions for rodents to thrive. And those rodents are the very species most likely to give us future zoonotic diseases.
Well, that certainly puts things into perspective because, while most of us may not visit or engage in a wet market ever, we all live presumably very close to rodents to some extent. But help me connect this here. When we talk about eroding biodiversity, what does that mean? One may be able to visualize, the physical impact on a habitat, say, of a farmer in a third world country. He's clear-cutting a rainforest so he can now grow a palm crop to get the palm oil that he's going to use to earn a living to sustain his family. And as a result of that action, it's now pushing people into a forced interaction with wildlife, advancing the potential of a virus transmission. I can visualize that. But what does that mean for the average person, and how are we contributing to that risk?
Well, again, I think your examples are interesting. I mean, the average person depends a lot on where we're talking about. I'm talking to you from upstate New York in a lovely rural community, and here, the kinds of impacts that an average person are having, the kinds of impacts that someone like me or someone I'd run into in my community is having, those impacts are largely driven by the choices that we make in our daily lives, like how much we drive, because that has effects on climate change. And in particular, when it comes to emerging infections, a lot of the choices we're making is about what we consume. So what we consume for food, what we consume as purchasers of products. Are we buying, if we consume animal products for our food, we actually have a big effect on biodiversity loss and also on contact between humans and wildlife, because going to a wet market is one source of creating a sort of danger zone for transmission of a zoonotic disease, but you're also creating one, although not necessarily one that will immediately affect you, if you're buying meat from someone who's grown raised cattle in South America and shipped the beef here, because those cattle were probably raised at the edge of a rainforest in high density conditions, right alongside creatures that could be transmitting a zoonotic virus. So we make choices as consumers all the time. And if I had to give people who are living in circumstances similar to mine advice, I would say to really think hard about your patterns of consumption, in particular to cut back on your consumption of animal products and not to buy more of anything than you need. And you probably need less than you think you do. People in other communities sometimes have fewer choices about what they consume, as you say, because they're trying to protect their families. And so we need to think really hard about how some of the choices, like the palm oil choice that you suggested, that a person living in somewhere in Southeast Asia might be making, those choices are often driven by the choices we as consumers are making in other parts of the world. So again, we could be providing better options for people halfway around the world if we were making better choices ourselves.
So would you say that perhaps one of the most important aspects here, if we are going to address and limit the risk of future pandemics, globally we have to start thinking differently? We have to come up with an alternative model that, among other things, includes not only healthcare readiness, collaborative research, but also some form of sustainability options for poorer nations. And ultimately, that starts right here at home as consumers. And I'm guilty of it too. I'm blessed. I've been cocooning at home for weeks. I'm in this safe environment. We just bought a new laptop for my kids to do homeschooling. I get my groceries delivered. My kids are healthy and safe. But there is a cost at the end of that. The free world is almost pressurizing the conditions for another pandemic.
We are the choices that we're making in here, that my family is making in New York and your family is making in Toronto, absolutely have effects around the world. So I would agree with that. I think we all recognize that we're in the midst of an unprecedented global challenge. Now, it's not that we could make comparisons to the 1918 global flu pandemic, but even then, we weren't connected and aware of what was going on around the world the way that we are now. We didn't have all of the technological capacity that we have now. You and I wouldn't have been having this kind of conversation back then, so that we could compare strategies and think about what we could do about this. So this is really an unprecedented scale of challenge, but it's also an unprecedented opportunity, right? We are going through a global reset, and we are going to have to make choices as we come out of this. Are we going to have the opportunity to make choices as we come out of this about what kind of world we want to be living in then? There may, in fact, be things about this world that we appreciate, like reductions in commuting time for some people, like hazard pay for some people who have particularly important and difficult jobs, like how we consume products. I think people are figuring out just how much less they need than they thought they did, about where our food comes from, about how we relate to our local environments, but also our global environments, how we're going to structure our economies. Here in the United States, we clearly need to think very carefully about how we want to structure our healthcare system so that we never face a ridiculous situation like what we're dealing with right now again. So again, a tremendous challenge, but also a tremendous opportunity for us to take advantage of this reset and do things better the next time.
And it's easy to think the source of the problem is only overseas, wet markets in China. But wet markets occur all around the world. And while many view it as barbaric, sadly, whether we like it or not, these markets provide food and income for millions of people around the world. So a global ban on them sounds like a perfect solution, and I'm sure you could get many nations on board to support that call to action. But how do you enforce that? Ultimately, that's only one part here. The other part, equally as important, is that the rest of the world has to step up.
That's absolutely right. I mean, when we're thinking about banning wet markets, whether they're in wherever in the world they are, we have to be thinking about the forces that lead to wet markets in the first place. Sometimes that's consumer choice, but not always. So, for example, there's a wonderful case study from West Africa where people along the coast, I believe it's Guinea in West Africa, um, uh, typically fish for the protein to feed their families. But when global ocean circulation changes, fish are not necessarily where they have historically been, and that means that people along the coast have to find another source of protein. And those are the circumstances in which people will go into the forest and find protein in the forest. So we need to be thinking about how we make sure that people and their families, people around the world, have access to protein sources, and what responsibility nations that are the people who are most responsible for causing global climate disruptions, for example, have towards people who are living through the consequences most acutely.
Was this pandemic preventable?
Yes, and multiple stops along the way. It would have been preventable if we had set up certain kinds of surveillance, for example, early on. It would have been preventable if we had stopped these kinds of wet markets in the first place, if that is indeed where it originated. But we also had multiple moments along the way in many different countries where we could have stopped it, largely if policymakers had listened more closely to public health experts and other scientists. I mean, we have examples here from the United States where public health experts saw more clearly, and physicians in some cases saw more clearly what was happening and asked for support and help and didn't get it. So the time to stop this was when the first cases arrived in any particular location, and quick testing, quick quarantining, and quick contact tracing could have contained it so that it didn't spread any further. But pretty much everybody dragged their feet on that. There are a handful of countries that didn't. And in those, they are driving this down to zero. But everywhere else, we were a little slow. So it was not only preventable in the first place, but it was preventable in a number of places. We didn't need to see anything like what we're seeing in the United States. Nothing like this needed to happen.
No argument here, but I have to ask you, could this happen again?
I mean, we could certainly see a scenario like this happening again where there's a jump. If we're smart enough, we'll prevent it. And one of the interesting things is when we prevent them, we don't know we were successful, if that makes sense, because we don't know just how far it could have spread. So imagine if, do a thought experiment where we wind back to November or December in that Wuhan wet market, and that jump occurs, but there's better surveillance and there's a better public health infrastructure and there's better reporting, and the Chinese government does a better job of listening to physicians who were reporting early suspicious pneumonia-like cases, right? That we would have prevented this potentially then, and we would never have realized how devastating it could be. So we wouldn't necessarily have marked it as a success. There's something similar happened with MERS and SARS. We stopped those. They could have gone much further, but we stopped them. There are reasons why they were more stoppable than this one, but they were stopped. And so we don't think of those in the same category. So we have to also acknowledge that success, that we have to pay close attention to what success looks like. It looks like something not happening instead of stopping something that's already raging.
Yeah, I get it. It's about being proactive instead of reactive.
Absolutely.
Well, one can hope at the end of this, COVID-19 will at least be a catalyst of change. It's clear we can't go back to what we were doing. So for the planet as a whole, I think we need to reestablish some sort of equitable balance to ensure the well-being of people and nature. It has to include biodiversity, or the most threatened species may be us.
Yeah, I don't think we're close to the most threatened species, although we could experience some serious damage as a species. There are species at far greater risk, and we will be the ones who do them in. I just close by saying in the biodiversity sphere, the next zoonotic disease that jumps to humans isn't going to be from a rhino, it's going to be from a rat. And the rhinos are going to be the ones that go extinct first. So rhinos and other large creatures are protecting us from plagues of rodents, essentially. So, we should be seeing this. You can call it balance if that feels right. What we need to be doing is making more space for nature. It's really that simple. We need to be making more space. We need more quantity of space and higher quality of space for wild creatures. That's in the best interest of every creature on the planet, including us.
Well said, Felicia. I think we'll leave it right there. We have unpacked so much incredibly important information on the pandemic, and, we really appreciate your expertise today.
It's been a pleasure. Great questions. Thank you for having me.
My guest has been Felicia Keysing. She is an ecologist and educator at Bard College in Annandale, New York. Time now to travel the world with another edition of the Blue Files. It's hard to imagine, but you can add inaccurate weather forecasts to the long list of impacts due to the coronavirus. Weather agencies around the world rely on constant weather data that is gathered by thousands of planes flying overhead to help project weather forecasts. That crucial data has been cut by as much as 80% since most flights have now been grounded. However, Lauren Gatches from NOAA, a main weather agency in the United States, says they are finding ways to compensate by using valuable aircraft data from cargo and package carriers. It should also be noted that billions of observations from other sources, including weather balloons, surface weather observation networks, radar, and satellites, are also routinely used. However, one study conducted by a European weather agency concluded that removing all aircraft data from weather models reduces accuracy by 15%. Let's hope researchers get the forecast wrong in this next story. Scientists are making a prediction of green snow in parts of the Antarctic coast. Researchers from the University of Cambridge and the British Antarctic Survey have created the first ever large-scale map of microscopic algae as they bloomed along the Antarctic Peninsula coast. Scientists identified over 1,600 separate blooms of green algae on the snow surface, covering almost 2 square kilometers. Green snow algae is microscopic when measured individually, but when the organisms grow simultaneously, they turn the snow bright green and can even be spotted from space, according to a published study in the Nature Communications Journal. Indicators are that this green snow is likely to spread as global temperatures increase, which may also lead to further snowmelt as the dark green snow will absorb more light than it reflects. The auto race is on. General Motors has announced that they are almost there on producing a 1,000,000-mile electric vehicle battery. Current EV batteries typically last 100 to 200,000 miles. Tesla is also getting ready to introduce a long-rumored, lower-cost, longer-lasting battery for its electric vehicles by early 2021. Long-range batteries are expected to lower the cost per kilowatt-hour to under $100. Many experts believe that reaching that mark would allow Tesla or other automakers to sell electric vehicles for the same prices as gasoline-powered ones, making them far more accessible. We'll continue to watch that one to see who wins the race to be the first on the market. And that's this edition of the Blue File. And by the way, all of our Blue Files are loaded up on the website, each edition with pictures. If you get a chance, check it out. There's a whole library now of really fascinating stories. I'm also putting together this month's edition of the Big Blue Marble newsletter. Be sure to sign up for that. It's 100% free, and subscribers get exclusive access. We have readers now from all around the world, which is just fantastic. Again, it's once a month and only available to our subscribers, and you can do that at bigbluemarble.earth. Speaking of which, be sure to subscribe to the actual podcast, and please share it. It's the only way this program can grow, and together we can help our changing planet. As always, you can also reach out to me via Twitter and on Instagram at Anwar Knight. I really appreciate your support when you follow me and repost show updates. But that's it for now. I'm Anwar Knight. Be well, my friends. Stay safe, and have a great day on the Big Blue Marble.
That was a great show, Daddy.